Well, first of all, I want to thank Mary and Debbie and everyone at NCPTT and the Park Service for putting this program together. I think it's been wonderful. I've certainly enjoyed it, and I hope you all have as well. I also want to recognize the Park Service. I think we often talk about the level of deferred maintenance, very inadequate budgets, and those are both very negatives. But I think what has always impressed me about the Park Service, probably more than any other of the government departments that I work for, is their ability to do so much with so little. And I think we need to recognize that as well. And finally, I do want to thank all of you. For those of you who've been counting, this is the 12th presentation in this room today. So congratulations. I am very conscious of the fact that I am what stands between you and your next installment of the Margarita Trail. So I'm going to be brief. I did take Mary at her word for, I think, Sean is here, so I know at least one person has heard me speak before. I love slides, and I love to talk. So to keep it to 20 minutes and to 25 slides was a challenge for me, and I took it. And I'm going to be very brief. These are two ongoing projects, and so I've tried to limit my comments, and I solicit any questions, comments, criticisms, or whatever, because we are definitely still now we're in construction documents for both of these projects. So anything that you tell me can potentially inform what we're doing. When I got the call for papers, I talked to my colleagues at EYP, and we're like, well, we've worked for the Park Service for decades, and we've worked on a lot of great historic resources. None of them were Park Service-built facilities. So what should we talk about? And I knew that there would be colleagues here who would talk about iconic visitor centers, and certainly we've seen several of them here today. And so I took a slightly different tack. A lot of the work that EYP does for the Park Service is under IDIQ contracts, both for the Northeast region and National Capital Region primarily. And a lot of these are small task orders. So I sort of, after hearing Caleb Waters talk yesterday, I look at my presentation as sort of the design professional's corollary to his. He talked about maintenance and maintenance budgets. What I'm talking about are these smaller task orders and how to implement them in a way that maximizes the budgets they have and balances the preservation concerns with the programmatic concerns, with the sustainability goals, et cetera. I am going to cut out my little introduction that talks about Mission 66 and the history of park-built structures, because I think we've all heard that. In fact, I don't know how many times today I have seen this slide, but quite a few. So and certainly Jeff Pappas' presentation earlier today gave us an excellent background into particularly Mission 66. But as we have heard, many of the park facilities built by the service over the past century are now significant historic resources in their own right. And certainly the one, although now gone, the Neutra building at Gettysburg, but all, of course, the Park Service buildings resulting from Mission 66 as well. The challenge for the next century is balancing the preservation of these resources with their rehabilitation and modernization to serve the needs of the Park Service, its staff, its volunteers, and its visitors for the next 100 years. The two case studies that I'm going to talk about from the Northeast region, one was a result of the Mission 66 program, although by an architect that I don't think anyone recognizes. It might be the smallest visitor center we've seen today. So I was talking with Tim Mitchell earlier today, and we were discussing the fact that this visitor center might be forgettable. But that might be a recognition of its success as well. What the visitors remember from visiting this site is not potentially the visitor center, but the other historic resources. And the other was built in 1967 for Pennsylvania's first state park. And each of these I've chosen to illustrate sort of the strategies and lessons that we've learned from how to achieve modernization of these facilities that still balances preservation and sustainability. Booker T. Washington National Monument near Roanoke was established to protect and interpret the site of Booker T. Washington's birth, its cultural landscape, and the viewshed. The park also memorializes and interprets Booker T. Washington's life, his historical contributions and accomplishments, and his significant role in American history. It provides a focal point for the continuing discussion about race in American society and about the legacy of Booker T. Washington regarding that issue, and it provides a resource to educate the public on the life and achievements of Washington. And this is an image of the Visitor Center, which was completed in 1965 under the Mission 66 program. And this is a plan of Booker T. Washington National Monument. The north is to the left. You can see the Visitor Center here with an access road here, and then you proceed through the Visitor Center and then out to the landscape and the various historic resources from the plantation. The Visitor Center, again, was constructed in 1965. It's a wood frame building which originally housed approximately 5,500 square feet of area built on 2 levels. The main building housed a lobby, exhibit space, a small bookshop, and offices. And then later, which you can see on the right, a restroom building was added to accommodate increased visitorship. A maintenance shop was attached to the west end of the building on a lower level. The park's visitation grew substantially, and since the building was originally constructed, and in 2010, a new multi-purpose room was added to the facility, which you can see here, built out in front of the facade of the original Mission 66 structure. Additional office space over the maintenance shop was also anticipated as part of that 2010 plan, was taken through construction documents, but was not constructed due to budget constraints. Here you can see an interior of the multipurpose room from 2010. This is an image of the original lobby. I think probably similar to many of these structures, unlike some of the more iconic visitor centers, there are very few images of these, historic images of these buildings. There were no original drawings, or limited, actually there were a few, but very limited. But here's an image of the historic lobby with, similar to the idea of circulation discussed this morning, but with a glass entry wall on the right-hand side. You proceeded through this sort of orientation space with its exhibit area, and then out through glass doors on the back facade and out to the landscape. Here are some images as the visitor center looks now. Again, as discussed earlier today, this sort of use creep that's occurred. The bookshop has grown and taken over about half of that lobby, as well as the addition of an staffed information desk that projects out into that lobby space. The layout of the existing office space is quite compact, to put it mildly, and certainly does not meet staff and volunteer needs. Also designed and constructed prior to the enactment of any disabled access legislation. Obviously, the space does not meet any of the required clearances for wheelchair use and does not meet any current accessibility codes. And you can see here that every inch of space is being used. These office interiors were modified over time slightly, so that most of the finishes you can see here are not original. The steel windows are, but they are single glazed, and what's a little hard to make out in these images are interior storms that were added that make the operation of the hoppers somewhat problematic. The visitor center currently has a fire alarm system, although not code compliant, and it does not have a fire suppression system. Water is currently supplied to the visitor center by 2 wells on the property, and the building's not connected to the municipal water system. Based on the Park Service's mandate and focus on fire protection, at the current time. The purpose of the current task order was to provide a new fire suppression system and an upgrade to the existing fire alarm system, including the insertion of exposed sprinkler piping and heads in the historic lobby and exhibit areas. In order to provide adequate water for this fire suppression and system and domestic use, the building will also be connected to the municipal water system. And so this is a drawing of the proposed sprinkler layout on the main level. As you can see here, the existing office area, the proposed office addition, and the multipurpose room all have existing dropped acoustical tile ceilings. So there, the sprinkler heads will all be concealed heads with the piping above the ceiling. In the historic lobby, a single pipe will run across behind one of the exposed beams so that when you enter the building from the parking area here, it will be invisible. It's only when you're returning from the site to leave and you enter through the back that if you were to look straight up, you would see that pipe. It'll be as concealed as we could get it. There's obviously no concealed space above the ceiling in the lobby. And then in the exhibit area, this wall has been furred out for interpretive reasons in a previous renovation. We will be running the sprinkler pipe behind that so that all of the fire suppression in the exhibit area and the lobby will be provided by sidewall heads. So as minimal intervention in those spaces as we could get. We have proposed a full dry pipe system for the building. There are existing attic spaces above the office and the multipurpose room requiring dry pipe for those areas. The park staff wanted a wet pipe system to avoid the annual valve testing and maintenance that's required in a dry pipe system. We looked at ways of achieving the required climate control in the attics in order to provide a wet pipe system there. They really proved impractical. And a two-part system with dry pipe in the attic and wet pipe on the main floors really maximized your sort of first cost for construction while basically not alleviating the need for that annual maintenance. So the decision was made to go ahead with a full dry pipe system. In addition to the fire suppression, the scope of design included renovation of the existing office wing to meet space and accessibility requirements. This was based on the 2010 plan with some adjustments and made for programmatic reasons. And a new office addition above the maintenance shop has also been designed to complement the Mission 66 structure while providing much needed staff and volunteer space and a new library and conference room. All of the work is anticipated to be constructed while the building remains in use. And here you can see this is the original office area, reconfigured again primarily to provide handicap clearances to all of the spaces. And then this is the addition over the maintenance room below. And then an elevation of that addition. Again, trying to be compatible and sort of designed appropriately with the existing Mission 66 structure to the left. But, and this was not easy to do because the ceiling heights in here are not that generous to begin with, but to bring the roof line down so that those exposed beam ends of the original gable are still visible above the new roof. Okay. Case study number 2. The administrative building of about 8,600 square feet and the auditorium of about 4,200 square feet at Valley Forge National Historical Park were constructed by the Commonwealth of Pennsylvania in 1967 in advance of Valley Forge becoming a National Park Service unit in 1976. Both buildings are 2 stories connected by a covered breezeway with stone masonry exteriors designed in a regional vernacular to harmonize with the historic Valley Forge landscape. Occupancy and use of both buildings are year-round and essential to the park services or to the park's operations. And here you can see a historic image of both buildings. This is a plan of Valley Forge. North is up in this, or almost up in this case. Philadelphia is sort of down to the bottom right. The visitor center complex is here on the eastern end of the park, again with its ubiquitous loop road. And the complex consists of both the two buildings that I'm looking at, which are the auditorium here and the administrative building here, as well as a later visitor center constructed by the Park Service. But although it's not part of our task order, it is considered sort of one functioning complex by the Park Service. And then again, a more contemporary image of the two buildings. The purpose of the current task order is to modernize the existing HVAC systems in both the administrative building and the auditorium by developing design solutions for the replacement of the existing 100-ton water-cooled reciprocating chiller, for the replacement of the electric resistance variable air volume boxes and supplemental electric baseboard heat that provides heat to both buildings, and for new ductwork to distribute the conditioned air more effectively. And here's a current image of the auditorium. Again, limited sort of interior photos of the buildings. This is a historic image of the auditorium, and a more recent photo. Very few changes to the interior of the auditorium. The administrative building was never really designed with significant historic interior or significant interiors, and it's been muddled and modified over time, so that what little integrity that interior may have had originally is almost entirely gone. But the auditorium does retain some. And then here an image for you mechanical geeks in the audience. A historic image of the mechanical system on the left, a contemporary image on the right, a contemporary image on the left. Basically, the takeaway from this is they're exactly the same. So there have been minor modifications and repairs and some replacements over time, but basically these buildings are running on the same mechanical systems that were installed in 1967. EYP retained Simpson, Gumpertz, and Hager, SGH, to perform high-tech, non-destructive analyses of the administration and auditorium buildings, including both infrared thermographic survey and blower door air leakage testing, to understand the existing conditions and help inform our work on the project. SGH interpreted the test results of their air leakage testing to indicate that the air leakage rates at both buildings are grossly higher, and that meaning 2 to 7 times higher, than the relevant standards for new construction. They also cited a report from 1986 that looked at existing sort of office buildings and found that the administration building had air leakage and energy use that was approximately 4 times what one might expect from a comparable building. So significant air leakage and energy loss in these two buildings. The entire visitor center complex, so these two buildings plus the later glass and steel visitor center, have monthly energy costs of $10,000. So there's significant opportunity to improve on that by addressing these buildings. And here you can see just some images of some of their work. Here, the blower door equipment in place. Here are some of their thermographic images of the two buildings. And I don't think any of this is surprising, where they saw significant air leakage and heat loss around openings, mostly doors. The windows on these buildings have been replaced fairly recently, so the seals around those windows and the windows themselves are fairly good, but the doors had not. So those were an issue. Basically, intersections between the masonry walls and the roof, intersections between chimneys and the roof, here the cornice, the louvers at the attic, although louvers at attics are supposed to vent, so this one is actually doing what it's supposed to do, and again, some of these other connections. We also brought in the White Group, which is EYP's energy practice. to look at and to perform a preliminary digital energy analysis using DOE 2.2, which is a sophisticated building simulation program that performs thermal and illuminance calculations on an hour-by-hour basis. It uses typical yearly climatic data to determine the energy loads and system requirements for the building. And again, we brought them in at the beginning of preliminary design, and with some very simple information, most of which you can see here in terms of building configuration, square footage, and energy costs, as well as the floor plans that we had so they could get some room usage information as well as square footages. They were able to give us some very good comparative information on options for the building systems. The focus of the analysis was to compare the impact of 7 HVAC system options on the energy use and costs of the building. And these are the 7 options. And I'm going to go through them not quite in the order they're listed in an attempt to make it a little easier to understand. Option 3 is the existing building configuration with a water-cooled chiller and electric heat. Obviously, we would be replacing all of the equipment, but basically using the same system type as existing. Option 4 is to again use a water-cooled chiller, but bring in natural gas to provide the energy for the heating. Options 1 and 2 are similar in that they use electric heat and natural gas, but replacing a water-cooled chiller with an air-cooled chiller. And the significant advantage, there are several advantages to that, but one primarily is an air-cooled chiller does not have the danger of Legionnaire's disease. Option 5 was a ground-coupled water-cooled heat recovery chiller, otherwise known as a geothermal system. As I think is obvious to everyone, when you're dealing with a site such as Valley Forge, every square foot of undisturbed landscape is a potential archaeological nightmare, to put an editorial comment on it. And so while the Park Service was interested in seeing how a geothermal option fit into the cost and energy use information, it was really not considered a viable option for that very reason. And then finally, options 6 and 7, which are virtually the same as options 1 and 3, would be where the electricity for the electric heat would be provided by a photovoltaic array. Valley Forge is looking at providing a photovoltaic array as part of renovations to the visitor center and that whole visitor center area. So that's something a little more longer term, but they wanted it included in the options to see how all of that shook out. So here you have sort of the energy use results from that analysis. And I won't go into what the colors basically mean. Quickly, green is equipment, blue is lighting, purple. I don't remember what WH stands for. If anyone knows, tell me. Or it's the end of the day. Fans and pumps, cooling, and heating in red. And it might be, I think it is water heater, but yeah. Solar? I don't think it's solar. The takeaway here is basically that options 2 and 4, which were the natural gas options, use slightly more energy. Options 1 and 3 are the electric options. Option 5, not surprisingly, the geothermal option, uses considerably less energy. And then, of course, options 6 and 7 are going to be identical to options 1 and 3 because the energy is still electricity. It's just being provided by the sun and not by the public utility. So in terms of energy use, options 6 and 7 are the same as 1 and 3. Where you see the difference is the annual energy costs. And while options 2 and 4 were less than the electric, because the natural gas was cheaper than the electricity needed for the heat, the decision was eventually made to go with an electric system because the hope is you're going to eventually end up over there. where your annual energy costs are virtually zero. So based on all of this investigation, we presented and evaluated these options in collaboration with the Park Service. And the intention, of course, was to upgrade the existing heating, the cooling, and the ventilation systems. And they're intended to provide a cost-effective system to better serve the HVAC needs of both buildings, to reduce fossil fuel consumption, the resulting CO2 equivalencies at both buildings. At the conclusion of this process, the Park Service has selected option 1, which is the electric heat with an air-cooled chiller, which hopefully will be adapted to connect to the future photovoltaic field as part of the renovation rehabilitation of the whole complex. And currently, as I mentioned before, we're providing currently construction documents for both of these projects.